Hello class. Today our topic is subtopic of magnetic effect of current. Topic is force on a charged particle inside the electric field. When a charged particle is inside the electric field, how the force act on the charged particle and how it affect the path of charged particle. This is an electric field set up, two plates. Electric field is set up here. Let me have a charge particle plus charge Q move with velocity v in this uniform electric field. Now the direction of force, because the electric field exerts the force on the charge particle in the direction of field. So force is in the direction of field, that is from positive to negative. Due to this force, the path of charged particle doesn't remain straight path or horizontal. This is the screen where we get the particle move in a parabolic path. And if this distance is x and this distance is y, so we explain that when a charged particle enter in a uniform electric field, the force of electric field will make the path of the charged particle parabolic path. The electric field E, v is the velocity of charged particle, and if m is the mass, this is the force exerted by the electric field on the charged particle. Along horizontal, the distance is x, and along vertical, the distance is y. Let the charged particle take t time to cover this horizontal distance or to cover this path. So time is distance upon speed, x upon v. And the acceleration produced in the charged particle is qe upon m. Now the path along the y-axis, vertical direction. Velocity is along horizontal, 0 into t plus half at square, half qe upon m and t square x upon v square. So this is qe 2mv square x square, and this is the equation of parabolic path. So the charged particle when enter in the electric field, uniform electric field, the force exerted by the charged particle exerted by the electric field make the motion of the particle in a parabolic path. As the charged particle when move in a magnetic field, there is also the force exerted by the magnetic field. Now the one point is clear that force of electric field make the path parabolic. And what is the force of magnetic field? When a charged particle enter in a magnetic field, this is called magnetic Lorentz force, V vector cross V vector, or its magnitude is VQV when the sine theta is a maximum. And where the theta is maximum, if we consider cross product, this is sine theta. If theta is a 0 or 180 degree, 0 or 180 degree, this force is a 0. Means if the charged particle move parallel or anti-parallel to the magnetic field, force exerted by the magnetic field is 0. It means when the theta is 90 degree, when the charged particle move in a perpendicular direction in an electric field, in a magnetic field, it will give the maximum force. Now we have two more terms to represent the uniform magnetic field. It is represented by the cross signs. This is also the representation of uniform magnetic field. Uniform. And this is perpendicular to the plane of paper and inward. Inward. And if they are represented by the dots, that is again the representation of uniform magnetic field perpendicular to the plane of paper and outward. We have considered this. Perpendicular to the plane of paper and inward. Now this force that is act perpendicular, because this is the cross product. This force, perpendicular force, doesn't no work. Like the electric field force make the charged particle to move along a parabolic path. This force is the source of centripetal force. Remember this, the magnetic Lorentz force when a moving charge particle, when a charge particle moves with v velocity in a magnetic field, the maximum Lorentz force is BQV and it is the source of mv square upon r. mv square upon r means centripetal force, means in this field charge particle move along a circular path. Move along a circular path. At this point v is the velocity, magnetic field. At this point v is the velocity. At this point v is the velocity. So the magnetic Lorentz force is the source of centripetal force which move the charge particle in a circular path of radius mv upon vq. So time period, to cover this, time period is 2 pi r upon velocity, or we can say 2 pi mv upon vq, or the time period is 2 pi m upon vq, means the time period of this motion is independent of the velocity of the charge particle. Reciprocal of this is called frequency and this is called angular frequency 2 pi by t. So when a charge particle move in a magnetic field parallel or anti-parallel, the force exerted by the field is 0, and when it is moved perpendicular to the direction, force exerted is maximum, and that force is the source of centripetal force. Make the charge particle to move along a circular path. Beside this, if the charge particle move along the direction theta, means the v velocity vector makes angle theta with the magnetic field vector. If we considering this coordinate x, y, z, and here v velocity, this is magnetic field b vector, this is angle theta. So it resolve into two components. One is along this cos theta and the second one is perpendicular, that is equal to v sin theta. This is v cos theta, cos component cos theta, and this is v sin theta. And we know the perpendicular is the source of centripetal force which move the charge particle to circular path. And again the same, the circular path, the radius is mv upon vq. In this case we can say the component sin theta vq and the time period is 2 pi m upon vq. This time period is independent of the velocity. So in this case again the time period is the same. It means when the velocity is inclined to the magnetic field, the normal component move the charge particle in the circular path. What this horizontal component? The component in the direction of magnetic field. It linear move the path, charge particle linearly, means if this velocity make it to circular path, then this velocity move the charge particle upward, and this path has become a helical path. This path has become helical path, and time period is again this. Then the distance between these two successive is called pitch of the helical path, called pitch of the helical path, that is this component into t v cos theta into what is the time period 2 pi m upon vq. So this is the base of our accelerator, that is called the cyclotron. Now this cyclotron is a accelerator which is used to accelerate the charge particle, positive charge particle like the protons, alpha particle, deuterons, positive. It was designed by the Lorentz and Livingstone to overcome the drawback of linear accelerator. Linear accelerator like the Van de Graaff generator, where the charge particles are accelerated along the length of the discharge tube, and that length is the drawback of that accelerator. So in this, the charge particle will move in a spiral path, circular path based on this. And its principle is positive ion can acquire a large energy with a comparatively small alternating potential difference. A positive ion acquire large energy with a comparatively small alternating potential difference by crossing the same electric field again and again in the presence of magnetic field also. Means positive ion in this move in a circular path which is covered by the electric field, and under the effect of magnetic field it moves along the spiral path because the magnetic field moves the charged particle along a circular path. And in this we have the two D-shaped chambers with a gap. In cyclotron, these are the two D-shaped chambers with a gap. And here this gap, we have the positive ions or charged particle which has to be accelerated. And these two are connected with an oscillator, alternating oscillator, which is the source of electric field, which provide the polarities of these D's, D1, D2, these D's, and two strong poles for the electromagnet that will be provide the magnetic field which is perpendicular to the plane of the D's, and this is the source of accelerating charged particle. When the charged particle is produced here and under the effect of magnetic field, this is moved along the circular path, and this oscillating electric field provides the polarity to the D's. Let's suppose at initial it is at negative polarity and it is at positive polarity. After covering the semicircular path, because magnetic field provides the source of centripetal force, and the radius is become mv upon vq. Now, after covering the semicircular path and come into this gap, it again gain energy, and at the same time the polarity of D's change. Now D1 become negative and D2 become positive. It has the energy, so it again move the semicircular path, come in the gap, again the polarity change, and it covers the maximum path. And when the maximum radius of the D's from the window, it strikes the target with a high energy, with a high accelerating potential, so that to give the next nuclear reactions. It means the charged particle always take the same time inside the D, always take, irrespective of its velocity and radius. This is a semicircular. So this is the path of radius, semicircular path. Time period spent inside the D r pi r upon V, and this is V into mv upon vq. This cancel. So time is bq. This is the reason the time spent by the charged particle inside the D's is independent of velocity and radius, because in each cycle velocity is increasing, because we are saying that the charged particle is accelerating, and if the velocity is increasing, so it takes the less time, but that increase in velocity is compensated by the increase in a path of radius. As the charged particle get accelerating, the radius is also increasing, which compensate, and the charged particle always take the same time to cover the semicircular path and come back in the gap with the correct phase of electric field, and when it goes to the maximum path, it acquires the maximum velocity. And the total time period is calculated the twice of this 2 pi m upon vq, and the frequency 1 upon t, and the angular frequency 2 pi upon t. This is called the cyclotron frequency. So it is also called the magnetic resonance frequency, because here we have bq upon 2 pi m. So this is the cyclotron, and where it gets the maximum velocity when this radius is equal to the radius of d's. And how we get the maximum velocity? Maximum velocity is considered as bqr upon mv, and the maximum kinetic energy is the half mv square maximum. So this is the cyclotron, which is used to accelerate the charged particle by using the electric field and magnetic field. What is the role of electric field? That is the oscillating electric field, which provide the polarities to the D's to cover the path. And what is the role of magnetic field? It provides the source of centripetal path so that the charged particle move along the semicircular path inside the D's. Now, it is not used to accelerate for the electrons, negative or the light charged particles. It has some limitations. Here we have a point that the time spent inside the D is independent of the two factors, velocity and the radius, which two are changing or increasing in this case. But according to Einstein, when the particle is in motion, its mass is variation in variable form according to this relation 1 minus v square upon c square. This is the rest mass. Then this time period may be written as vq m naught 1 minus v square upon c square. So here the problem arises because the time spent include the velocity, which is keep on increasing in the cyclotron. When in each cycle, in each circular path, v is increasing, this factor is decreasing, and this t is increasing. Means charged particle take more time to spend inside the d's, and the phase between the change of polarity of the d's by the electric field and the charged particle is disturbed, and it doesn't cover the full cycle and don't get the accelerated. It lost by colliding the walls of the d's, but it can be removed. This factor, when it is increasing, this factor is decreasing. We compensate this magnetic field from outside. It is from outside the cyclotron source. So when we compensate this, to compensate this loss, time remains same, and this where we change the magnetic field outside is called the synchroton. Means this cyclotron is also called the magnetic resonance oscillator, because here the magnetic field is adjusted to cover this. And the frequency, that is 1 upon, this frequency is 1 upon this time, or we can say that bq 1 minus v square c square upon 2 pi m naught. We can say this. This is the frequency of oscillator. Means when this factor is decreasing, we also change the frequency. Means we have the two methods to overcome this limitation. One is to compensate the magnetic field, and the second is to compensate the frequency of the oscillator. So these are the two remedies to overcome this limitation. And the electrons, they can't be accelerated by using the cyclotron because its mass is very small, and this variation of mass is very quick in the case of light particles, in the case of electrons, and they easily get out of the track and lost by colliding the walls of the cyclotron. So this is a very important concept for this plus 2 physics, cyclotron, and it is based upon that the charged particle acquire the maximum energy, acquire the large energy by comparatively smaller potential difference to cross the electric field again and again under the effect of magnetic field. So here the question is how the charged particle compensate, because the time spent is independent of radius and the velocity. Okay. Then we have a simple form, velocity selector or velocity filter. It is used in various numerical forms. Means it is a type of device where we have the two slits. We have the slits in this, two slits horizontally, S1, S2. And here we have the cross fields. Cross means perpendicular fields. And what are the cross fields? Electric and magnetic fields. This is the electric field. And here we can say that this is the magnetic field. So when the beam of charged particle enter here, two forces, BQV and QE. These two forces are exert on the charged particle. Now the particles moving with velocity v, independent irrespective of their mass and charge. And when they enter in this cross field, where the both fields, electric and magnetic fields, are present, those particles which move from this field by equalizing these forces is act as a undeviated and filter out from the S2. And these particles are used for the further experimentation form. Means this arrangement is a velocity selector. It selects those particles irrespective of their mass and field, under which these two fields become equal, and the velocity, this velocity is become E upon V. So this concept is used to calculate the velocity, or if we have electric or magnetic field. Okay. Then we have the force on current carrying conductor placed in a magnetic field. Now at the starting of the lecture we have studied that when a positive charge or when a charge move in an electric field, it experiences a force, that is QE, which make the path parabolic. And when the charge particle move in a magnetic field, that force move the charge particle along the circular path. Now we have the force on a current carrying conductor placed in a magnetic field. Current carrying conductor placed in a magnetic field means if we have a conductor, this is a conductor that is placed along, we say y dash, and here is a magnetic field along z-axis. Magnetic field. This is the length of the conductor. Then electrons, they are moving, and how the current is flow there? With the help of drift velocity. Let me say that this is the direction of current. Now we considering current element, IL vector, current element vector, current element vector. Now the drift velocity and current element, they are opposite, and this whole thing exert the force that is along x-axis. Exert the force that is along x-axis. Okay. So we are considering that this is a conductor of length L, and it is placed in a magnetic field. It carrying the current along the y direction. IL vector is a current element vector. A is the area of cross section of the wire through which the current is flowing, and the name of wire we consider PQ is the name of a wire. As we know that current is NAE, drift velocity, that we have studied in current electricity. If we multiply both sides with L, both sides, and draw the vector here, this is negative sign. Why it is negative sign? Because the current element and drift velocity, they are the both in a opposite direction. Now this is equation 1. Force on a electron. Electron, they are the flow of charges for the current, so they are considering as a charge particle. So force on one electron is minus E drift velocity cross B vector. And what are the total electron here? Number of electrons per unit volume into volume, number density. So net force is NF vector, means N minus E. This NF vector means NAL minus E drift velocity cross V. Put the values of this and rearrange these values. Minus NA LE drift velocity cross B vector, and by using this equation IL vector cross V vector. So when a current carrying conductor is placed in an external magnetic field, it experiences a force that is called BIL sine theta, and theta is maximum at 90 degree, and that force is become BIL. Very important term. Why the conductor experience the force? Due to the two magnetic field, its own magnetic field by its current and external magnetic field. These two magnetic fields interact with each other and exert the force on a current carrying conductor when placed in a magnetic field. First you take the current element, area of vector, current and drift velocity relation, L multiplication, force on one electron. How many number of electrons? Free electrons. This is number density. Multiply with the volume and get this answer. Direction. How we consider that this force is along x-axis? By using Fleming left hand rule. This first finger is magnetic field and the center finger is current direction. Then this thumb point out the force. If we consider that this is the magnetic field direction, this is the current direction, what is the force direction? Outward, means along this axis. This axis show the outward of this board. And when the two conductors are parallel, infinite current carrying conductor, they placed parallel to each other, then what is the force between them? Very important topic. Two parallel conductors placed parallels, two conductors x1 y1 x2 y2 carrying current I1 I2, they are placed at a distance r apart. Now these are the two infinitely long conductors. Now this conductor is placed in its magnetic field and this conductor is placed in its magnetic field. How we calculate? We consider this point P. Now by using right hand thumb rule, this one, this is current, the field lines in this point due to this conductor inward, means this is inward, magnetic field inward. Now by using this Fleming left hand rule, this is inward, this is the current, this is the force, means This is the force. In this conductor, force due to its field is towards it. Now we have a point Q. Now due to this right hand rule, the magnetic field outward at this point, this is outward B1 and Fleming outward current and force here. Now same current. Now if we consider here X1 Y1 magnetic field straight conductor to I2 upon R. Now this is the force per unit length. Why we considering it per unit length? Because it is a infinite conductors. Then force is B2, current is I1, per unit length is 1. So it becomes 2 pi 2 I1 I2 upon R. This is the force. Similarly, for this, if we have B1 mu naught upon 4 pi 2 I1 upon R, then F is B1 I2 into 1. Again we get this. So the two infinite parallel conductors carrying in same direction current, they attract each other with this force. And this force is used to define 1 ampere. Very important. To define 1 ampere. How we say? If we say -7, 2, this is 1 and 1, this is again 1. So it is 2 into -7 Newton per meter. Means if the two conductors placed at 1 meter in vacuum carries the 1 ampere current in each, if they experience the force of 2 into 10 raised to power -7 Newton per meter. So this is a very important how the 1 ampere current is defined by using the force between the two parallel conductors placed at a certain distance. If they carry the current in opposite directions, then they repel with each other. If we considering, because now the direction is changed at point P, this is the direction, means in this direction. For this is again the direction. So this is outward current, force is outward. Or here we considering the current is downward by Fleming rule. They are oppose each other with the same force. So this is a very important article. The charged current carrying conductor placed in a magnetic field experience the force BIL, and when the two conductors are parallel, if they carry the current in same direction, they attract each other with this much force, and if they are carrying the current in opposite direction, they repel each other with this force. Okay, thank you.